Good afternoon or good evening, depending on where you are in the world. Thanks for joining us today. My name's John Tobin from Trillio. We'd like to thank you for taking the time out to join us for yet another installment in our Ask the Experts series focused on cloud native data protection. Our hope's to provide some relevant topics and some discussion as well around various data protection challenges in a quick 30-minute lightning talk format. Again, this is a open forum, so please submit your questions. You can send them over to me through the chat. Again, my name's John Tobin. So send them directly to me and we'll talk to them at the end. Hopefully we'll be reserving 5 to 10 minutes at the end to address those questions. We're going to do our best, of course, to stick to that time frame. But without further ado, I'd like to introduce you to the ever kind and handsome Kevin Jackson to lead our discussion today. Take it away, Kev.
Cheers, John. Hey, you're being especially kind to me today. I appreciate that. It is noted. I might have to make some quick edits to my presentation. Anyway, thank you for joining us today. Today I've got the fortunate job of taking you through three of our environments that we protect, Red Hat virtualization, OpenStack platform, and OpenShift container platform. So I'll be taking you through the evolution of the journey. I'll take you through the various use cases of the various architectures, and of course, tying this into what we know and what we're really good at and what we know best, how to protect these different architectures. As John says, this is a bi-weekly discussion where we take on topics of backup and recovery. Interaction really is encouraged. I know you're all on mute, but please ask us questions. Bring your challenges and concerns over to us. I just want to point out that the first rule of Expert Club is you ask John the hard questions and not me. I'll also say that the second rule of Expert Club is we can change these rules whenever we want. You'll see on the screen, if we have the most engaged person on the call, there will be a $50 Amazon gift card winging its way over to you. So, who are we? So, I'm Kevin Jackson. I am one of our senior solutions architects that live and work out of EMEA. So I service our EMEA customers. And John, who you've just heard, John is my counterpart in the US, who is a taller, more intelligent, more handsome version of Kev. Hey, John, did you change my script again? Ordinarily, I guess I would call him a Muppet at this point, but I guess not today, because today is John's birthday. So, we'd like to wish him a very happy birthday. If you would like to send him a message, feel free. If you want to send him some kind of old man GIFs, he'll love to receive them. His email address is john.tobin@trillio.io. And I guess you could also try and guess his age. I reckon he would love that and not feel offended at all if you get his age wrong. But talking of birthdays and trying to hopefully get this talk back on track, OpenStack turns 10 today, and only recently Kubernetes turned 6. So two of the platforms that Trillio loves and protects, are celebrating their birthdays this week, this month. So happy birthday to these absolutely fantastic platforms. Moving on, right? Let's get back into why we're here today. So I'm going to talk you through the evolution of the architecture, as we know it today. So first, we had real servers. Anybody remember those days? Remember those days where you could walk into a data center and actually point at, say, the company's database servers, the financial servers, and the one with the sticky note on that said, "For the love of God, do not turn off this file server." I really, really miss those days. But then hardware became too powerful for its own good, I guess. So the clever people over at VMware, yes, they're the ones that that invented the virtualization for x86, the servers that we love today. They made software which allowed people to turn one server into many individual servers. And that was all good. That was all good for a long time. But then people realized that all these virtualized servers were essentially pieces of software. So then came the dawn of a new era of cloud computing, allowing people to programmatically orchestrate their use of these resources, such as virtual machines, and virtual storage and networking. And ultimately, the applications that run on them with, the key tenet here, the key feature here really is without, or as little as human intervention or tickets to the IT department. And of course, this was good for a few years before a number of people in the cloud world wanted to, I guess, redefine cloud. So we ended up in, I don't know if anyone remembers the last few years of, people trying to reinvent and reword the word cloud, meaning cloud and private cloud, public cloud, and the arguments around all this kind of stuff. So to avoid this confusion, along came cloud native, which is basically, I guess, the intent of cloud in the first place. But obviously the cloud word was already taken. You couldn't actually go back over the 12 years and actually, say, actually, you did something slightly different to what we thought cloud is today. However, we end up with cloud native. But one thing that I want to really highlight here is the fact that if you think about cloud, if you actually think about that middle graphic there, if you think about it, to launch an application, you had to provide VMs, network, storage. The key thing here is that you implicitly created those elements. Now, of course, it was very, very easy to do. There was an API, there was a standard API. That's what cloud is. It's these API standards that allowed you to control the virtual hardware. But cloud native strips away a lot of that implicit infrastructure thinking and moves to one that is more application first mentality. That's the difference. So what does that mean when we're talking about the platforms? When I said we're talking about the Red Hat platforms, that means that if we go back, in the virtualization world, we've got Rev. In the cloud space, we've got Red Hat OpenStack platform. And in the cloud native space, we're talking about Red Hat OpenShift container platform. So let's dive into these in a little bit more detail and the kind of use cases for these particular pieces of architecture. So of course, starting off with Rev. So Rev is essentially your enterprise server virtualization platform. So what that really, really means is, and when we boil it all down, is essentially efficiency of hardware and server management. It's a single tenant use space. So the reason why I put there, that's not a bad thing. This is the use case of Rev. The reason why I put there is it's obviously it makes the continuity of these slides a lot easier to understand. But effectively, you've got a single tenant space. The admin users basically control this particular environment. However, it's a multi-cluster, multi-domain world. The key thing here is you are effectively utilizing tools, the Rev Manager, to effectively manage multiple clusters and multiple domain installations of your virtual estate. So the kind of use cases that you would typically see and you would know and you love to look after these day in, day out are more of the static kind of workloads. But that isn't anything in a kind of in a world where, I guess, if you're a cloud person, you kind of like scoff at the idea of you know, hey, look, you run static stuff. Mine is all dynamic. It's not anything like that. This is the workloads which are the foundations for everything else that's part of your cloud world. But whilst it's virtual, if you think about it, this allows for the fast recovery of said workloads. It also allows for easier scaling of those particular workloads. And if I start to build out this picture, which I'll get to at the end, if you start to build out this picture of where this effectively fits and what we see a lot, working with a lot of organizations who are using this, you will see the effective use of Rev in enterprises today. You know, and typically this are the kind of workloads such as like management nodes, infrastructure nodes as part of, you know, a wider picture. Moving on to the Red Hat OpenStack platform. So obviously this is the world of infrastructure as a service. This is 100% API driven hardware management, virtualization, and orchestration. Now, I know that's a bit of a mouthful. You know, that's why I guess people prefer the word cloud. But ultimately, this is a world where it straddles kind of like two worlds. You've got the world which satisfies the IT department, and then you've got the world which satisfies the developers. And so this is a world which crosses the boundaries to where you've probably you know, been managing your services in you know, your virtual service in the old world, and this is a world where you move into the new world of potentially cloud native. But it's a jack of all trades, and certainly you know, and that's not a bad thing. This is a world where it fills the gaps and allows you to port between one place and the other. It's a multi-tenant self-service world. You can't have cloud if you don't have multi-tenancy and you don't have self-service. And any of the tooling around this, any of the features of cloud have to fit into the bucket of multi-tenant and self-service. So the kind of workloads that we see in here are obviously dynamic workloads. Again, if you go back to how people are consuming these workloads today, you will see the fact that they are utilizing standard tools. They're using standard tools, say Ansible, Chef, and Puppet, or Terraform. They are using the environment as a way of getting to a service deployment. But if you think about how to actually get to that service deployment, as part of that makeup, you are still asking the particular platform. In this world, we're talking OpenStack. You're still asking OpenStack, give me 5 servers, give me 20 Cinder volumes, give me 3 networks, and then go and create my environment. You know, from zero to service and producing the infrastructure, you end up with a complete picture of your particular service. And that's the key fundamental good points of how OpenStack is being used. We also see it in the world of NFV. I think this is almost an obvious use case. This is a world where we are seeing VNFs spun up as virtual machines within this environment. It naturally works very well in the world of virtual networking and SDN as part of the OpenStack stack. And so certainly from a Trillio point of view, we get to see a lot of this architecture where OpenStack is essentially I guess the heart and lungs of a lot of the infrastructure that we see today. And then we have the OpenShift container platform. Now, to a lot of people, this is relatively new. You've seen the fact that OpenStack is 10 years old, Kubernetes is 6 years old. So of course, you know, this is naturally on a curve where this is going to get you know, a hell of a lot more exciting as workloads pick up. But certainly, this is a world were, again, let's go back to that picture I drew before in terms of where cloud is today, or certainly the cloud platforms that people are consuming in the likes of OpenStack, and the world where cloud native is over the last couple of years in terms of people going and jumping into a cloud native application first world. They're in a world where they are defining their application where basically hardware is not a barrier and essentially data center is not a barrier too. For Rev and OpenStack, there's an awareness of where these workloads are running. In a container platform, there's less of that, I wouldn't say care or concern. I remember years ago having a conversation of how do I manage an application, and we're talking about 15 years ago how do I manage an application where I don't care where it's running from? You know, the OpenShift container platform in Kubernetes basically gives you that mentality because it's inherently portable. And by design, it's scalable. You know, as people consume this particular platform, they're not having to think too much of the mechanisms of how the infrastructure is going to scale my application. Sure, there's an awareness of how Kubernetes will do this under the hood, but ultimately, what happens here is the control or the development and the agile mindset moves to more of the getting applications out and used immediately. You know, more of a developer-centric world, without the constraint of how this application is glued together under the hood. I like to think that, you know, in a container platform, everything's assumed to be dynamic. Now, this doesn't mean that you have to run dynamic workloads. What this means is you just get the added advantage of it's there if you want to use it. Sure, lots of workloads would be dynamic by nature. Just think of microservices or any of the web scale architecture, which has to scale up and scale down in terms of demand. It's not as if OpenStack and VMs can't do this. The thing is, you'd have to know how to utilize the features, the specific features of a cloud to take advantage of those scaling. Whereas in the container platform world, it makes things a hell of a lot more seamless and moves the barriers away from the complexity of managing how to scale those services. And again, going back into the world of NFV, we're seeing a lot more architecture now where it's not just VNFs, so the virtual network functions, you know, where they run as virtual machines. We're seeing a hell of a lot more moving into the CNF world. So where the containers themselves are running those network functions. So tying all this together, we see a lot of this. We see a lot of the architecture where everything is glued together. So in a Red Hat world, we're seeing the likes of Red Hat virtualization, where it's running the foundation controller nodes of the rest of the environment. If you move along to the OpenStack column, OpenStack is great at you know, allowing you to scale out your services. So your infrastructure services on here. So if you think of scaling out your OpenShift worker nodes, OpenStack makes a fantastic platform for you to be able to scale those worker nodes out. Now, if you look at the far right-hand side where we've got some pods and containers running, now I appreciate the fact that, you know, for anybody who's quite astute here, they'll see the fact that my containers are, you know, slightly larger than my actual worker nodes. You know, I like big containers and I cannot lie. But yeah, this is not to scale, by the way. This is just more to highlight the fact that, like, you know, above the stack is your pods and containers. But if you glue all this together, what you've got is this fantastic environment where you've got all the best of all the breeds running in the world today, where you've got some static workloads running in Rev, you've got some fairly dynamic workloads and some even static management parts of OpenStack running, and then you've got your worker nodes running your actual environment, your actual applications, which basically appease your developers and basically appease the company because of the way you can scale this out. Now, of course, I work at Trillio, and the key thing about this is, watch this. Now watch this, because this is an amazing graphic, but this is us. This is us. We can come in very, very easily to protect all of these workloads. Now, whoever said red and green should never be seen, obviously never worked in the IT department. Now, of course, we're not particularly known for our fashion sense, but certainly at Trillio, we're very good and have very good common sense. And this makes great common sense of where you would protect your environment. So if you take your protection of your Rev node, so if you think of your virtual machines that are running OpenStack controllers, they're running director nodes, they could be running Ansible Tower. You can back all them up and have them recovered very, very easily. There are some complex servers in there. And if you think of being able to recover your OpenStack environment through one click, that's far above and beyond the complexity of having to manage recovery in any other world if they all go down. If you look at the OpenStack protection, we protect the virtual machines. We'll protect the virtual machines that are running on OpenStack. So if you think of any of those workloads, if you've got some management functions, any of the monitoring functions, whatever you've got running in OpenStack, we will protect them and the volumes around them. And then you move into the OpenShift world for, Trillio Vault for Kubernetes running in here. We'll be able to protect the actual running workloads itself. We'll be able to basically take your running application and again, seamlessly be able to recover them back into where it was. So I'm just gonna, if I wanted to really hammer home, what we really do here, we're natively part of these products. We're natively part of these particular platforms. And I can put my hand on my heart and say it's very, very easy to install because you know how to use these platforms today. So for example, installing Trillio into Rev today, it's virtual machines. If you are managing Rev, you already know how to install Trillio. When it comes to Red Hat OpenStack platform, it's a directed deployment. So you already know how to install and add our native service to OpenStack. And then when it comes to OpenShift, we're an operator installation. You can't get much more simpler than this. And if you look at this whole protection, that's what you get from us today. Just wrapping this up, I'll just build this out just slightly. So we're talking cloud native data protection. Now, of course, Rev's in there. It's part of the family. But what we've got is over years, so 7 years of Trillio, we've built up the experience of knowing what works and what is the requirement of cloud data protection from being fully agentless. It has to be agentless. You can't do cloud native protection if it's not agentless. You want to be able to scale with the architecture and let people worry about their applications and what they scale. So we scale with the architecture. Multi-cluster, multi-tenant. It has to work with multi-tenant. In other words, if you wrap the self-service element into this, it's a self-service multi-tenant product where we are fully integrated into those platforms. If we showed you the screenshots, in fact, you can go back a few slides, you would have seen the screenshots. They're actually Trillio, the Trillio parts of those platforms. You will see that we are natively part of those products. Scaling, again, this goes hand in hand with the likes of agentless. Look, if you think you can scale using agents and having to manage the different versions and stuff like that, I think, that's a very difficult world and a difficult, pill to swallow. So it has to be something which is seamlessly part of the particular platform itself, the cloud platform itself. Non-disruptive. Look, I think we have visited many sites, that maybe disappoint, when it comes to maintenance. There's some SaaS providers out there and say, oh, look, I'm down for maintenance. Look, for cloud data protection, you can't have this thing going, okay, can you just pause your VMs or your containers for 3 hours while I do a backup? That's not cloud. That's not the mentality you would expect. So we are fully non-disruptive here. And just to tie this all together, we have consistency throughout our product set. We use an open universal backup scheme. And just throwing this in there because it's just part of our heritage. It's just what we do, and we know it works very, very well. And it's a very, very efficient way of how we've been able to go from one product all the way through the family that I've shown. So I did a whistle-stop tour of the revs, the OpenStacks, and the container world. Feel free now to raise any questions. John, is there any questions that's come our way?
We do. We have some very good questions, Kev, as a matter of fact. And I'll point out you're right on time as well.
Amazing.
Always. Yeah, you guys can really talk. So we have one regarding kind of traditional backup tools, and the question centers around, why aren't traditional backup tools, which are focused, more on the infrastructure, why can't they catch up with, the cloud use cases like OpenStack and container workloads? And what would we expect the trade-offs to be for a customer, that has a tool like that?
Yeah, so I mean, let's start off, I guess, with the the good points. Look, we're talking tools which probably sit outside of the environment, where they have a multifunction purpose which allows people to do, I guess, file level or some kind of like agent-based kind of recovery. You get the central management, layer. That's something which is there. But I always find that's the key thing is that's not cloud, right? I mean, you'll agree the fact that, it's not there's no part of having a tool, a management tool, which is owned by the IT department. At no point is that ever going to be, a cloud native backup solution. So the advantages that you get for a cloud native backup solution are the fact that you start to utilize a product designed for that particular platform. Now, of course, we're talking data protection. We're talking the fact that we're trying to achieve the same goal of backup and recovery. But cloud, first and foremost, well, hopefully I've mentioned it a few times, but it's all about, it's a user-driven world. The whole world of shifting from the mentality of the IT department and ticketing systems has only gone away because of the fact that people start to use APIs and workflows to get the works done. There is no reason why backup and recovery and data protection is not part of that whole workflow. And in which case you start to get the efficiencies from think of a user point of view. They can self-serve the backup and recovery needs. They can self-report. They can utilize data recovery and protection in various ways that are better suited to their actual use cases, rather than thinking, okay, I need an IT department to now glue my pieces of my puzzle together. I don't know if you have any other points that you want to make on that, John?
No, I mean, I think you hit the nail on the head, Kev. I mean, if I could just summarize quickly, it's one, self-service, right? It's getting power back to the users. That's what the cloud's all about. And secondly, if you think of where just IT's gone in the last, let's call it like 40 years, apropos, is that everything has become a service and everything's been defined by code. So everything's turned into software in some sort, some form. And that's not just about servers, right? The infrastructure doesn't matter anymore. It's about the platform and it's about the application. And everything's become an application, including the networking. So when you want to back up an application, you need to back up its slice of the resources. And you can do that now in cloud platforms. You can do it in OpenShift. You can do it in OpenStack, right? And what you would be missing at an agent or at a physical infrastructure level is everything that defines that application. Right? We all know we use applications every day when we're banking, when we're interacting with the brands that we love, right? You want that application back up and running and in a consistent state as fast as you can. And doing that at a physical infrastructure level is extremely difficult because you have to piece back together something that's shattered into a million pieces, right? But when you can say, I just want to protect this application, you can get everything that you need to get that application back up and running as fast as you can. And we know backup and recovery is all about the recovery. It's all about the RPO.
Yeah, yeah. Cool.
Another question. This one's specifically about OpenStack, but it has to do with, I think, kind of chargeback, showback, and integration with Cellulometer, Kev. So I think it's about making billing easier, which I think is a big pain point for the OpenStack audience, and specifically how Trillio integrates with Cellulometer.
Yeah, Cellulometer. Yeah.
Sorry.
Yeah, so obviously Cellulometer is a metrics gathering tool, that basically looks at the metrics of VMs and the networking and storage and things like that. We don't have specific integration into Cellulometer. However, in terms of chargeback, because we have a lot of service providers that we work with, we obviously provide an API, where it's an OpenStack service. You would 100%, again, if there's anything you're going to take away from this, you're going to take away the fact that Trillio is, in this world and this very specific question, it's an OpenStack service. So you get all the goodness you would expect from an OpenStack service. You get tools, you get the command line tools, you get the API, you get the integration. Where there isn't the integration, obviously, is like I said, is with Cellulometer. However, we do provide our own RESTful API. We've got our own tools that allow you to extract the appropriate information in terms of what you would require as part of chargeback and showback. In terms of backup usage, in terms of the storage usage, in terms of the features you would expect to be able to bill people. And when I say storage fees, we're talking like where are they up to on the quotas? We support quotas at the back end for backup purposes. So I implore you to investigate those particular features. Whilst it's not tied to Cellulometer, we certainly operate in a wide gamut across the board in terms of service providers.
That's a good answer. I think the last one, we're a little over time here, but was just about NetApp, and specifically, if somebody's using NetApp and they're backing up using SnapVault or SnapMirror, what advantages are there to using a cloud integrated backup platform like Trillio?
Yeah. So I guess this is probably applicable to any of the platforms. But the way I'd like to see this, and just as a little caveat, I love NetApp. They were part of my life for a long time. Many years ago. But essentially, if you think of what's happening in a NetApp kind of world, those kind of snapshots are happening obviously at the hardware level. We kind of touched upon the point before in terms of the disconnect between IT view of what data and the meaning of that data, the function of that backup, versus the end user's view of that particular backup. However, the glue between the NetApp and your world would be either the Rev platform or say the OpenStack platform. Because we're short of time, on my, obviously I'll talk to death about OpenStack, but I'll try and be quick. In the OpenStack kind of world, if you think of Cinder, which has got the NetApp driver attached, if you go and do a snapshot using Cinder, it will invoke the NetApp driver and natively go and do those the SnapVault kind of functions, behind the scenes, which is all well and good. So that will allow you as a user, for example, to recover a snapshot of, say, a Cinder volume. However, that's not what we do. So in terms of Trillio and the advantages, doing snapshots of disks is not the end goal. But taking a backup of your workload, which has a purpose and a meaning in life, is the purpose of a valid backup and recovery. Put it this way, you could not do a one-click restore, for example. I'm not saying it's the be-all and end-all, but you could not do a one-click restore of, say, a Cinder volume and expect that to then be, a suite of web servers that are running to serve your website. At Trillio, you'd be able to define those web servers as a whole entity. We capture the metadata, the IP address information, all the good stuff that makes up the function of that particular application. And we back up all that as well as the disks. So you can't just rely solely on a disk backup. You've got to have somewhere where the metadata, the extra information is also captured. Now, however, I think an interesting use case, and I know we're very, very short of time, and I appreciate everybody's hanging on here. But I think the very interesting use case is a disaster recovery type of scenario. Now, of course, Trillio, isn't specifically a disaster recovery product. We are absolutely part of that particular process. But if you think of the world where the Trillio Vault storage is stored on NetApp, NetApp is creating a snapshot of your, well, it's in Snap Vault of your particular backup, and then sending that using SnapMirror to another data center. This is great. You've now got your data sent over to another site. Without Trillio, what would happen is you would snapshot your Cinder data. That Cinder snapshot will be sent over to the other remote site. The problem is, if you flip over to that other site and expect to be able to use that data, that is just a SnapMirror from Cinder from data center 1, it unfortunately loses its identity, has no meaning for the OpenStack world that it wants to reattach to. What we do at Trillio is we store that data in a, put it this way, it's less encapsulated to the original data center. We store the data, which allows us to recover that workload into Cinder volumes that are relevant into the new data center. So we take a slightly different approach that you just cannot achieve using traditional type SnapMirror functionality in that kind of context. But I know I'm out of time. I could talk about this for a lot longer, but hopefully that will answer the question.
I think that was a good answer, Kev. So I guess we're out of time for today, but thanks for joining us. And we'll be doing this again on July 30th when Prashanto, our product manager for OpenShift and Kubernetes, will be talking about the top 4 reasons why you need cloud native data protection for Kubernetes. So please come join us.